We'd like to welcome everyone today to our 30-minute Aras Innovator webinar. We're going to focus on requirements management today. So typically we try to keep these webinars to all demo. However, we'd like to take a few minutes to preface the demo with a few slides around what requirements management is, why it's important to your organization, and how Aras Innovator and their embedded requirements management solution can help you. Just a few quick interactions as to who we have on the call today here at Javelin. We've got Mario Viteri, he's Western Regional Manager and PLM Product Manager at Javelin. Myself is Susan Rockefeller. I'm a Project Manager and the PLM PDM Specialist for the Javelin team. And we have Sarah Pugh, who's our Marketing Specialist focused on PLM and 3D printers. Our email contact information is here. Please feel free to contact any one of us after the webinar. So why manage requirements? Requirements it's important to manage your requirements. And Institute of Configuration Management, some of their information includes about requirements management, that requirements get no respect. So let's talk about why they should get some respect. Requirements are the voice of your customer. They're the building blocks of your products and systems. They're verification that you're building what you intend to build. As well, they're being essential to defining and validating your design and quality goals. They are part of your overall system configuration and an intellectual property asset, but most importantly, they are absolutely critical to your ability to develop today's innovative new products and complex systems. Let's talk a little bit about innovation and where it's at. When you look at the pace of innovation, it continues to accelerate on a global scale at each of our companies and in all industries across the board, especially in emerging markets where all our companies do business and where we're all seeing aggressive new competitors sprout up each week. It's happening in our international supply chain and the next generation systems that our companies are all working on. Innovation is happening now at a scale never been seen before by mankind. We may notice it every day at work, but we're certainly experiencing it in our own lives on a daily basis with new electronic devices, household products, consumer services. We're all realizing the tremendous benefits that the innovation brings to our lives. And there are new innovations coming out constantly at an ever-increasing rate. Aras sometimes refers to this as the relentless pursuit of new. But there's a flip side to all this innovation. It's complexity, an ever greater complexity in our products and systems, and it's not slowing down. And it's not going away. And it has some profound implications for the way we do things every day. So if we take a look at something that we all know and we all love or would love to have, is a luxury vehicle. Something like a Lexus LS. And what the innovation and complexity implications have been over the past 5 decades. In 1970, the average luxury vehicle had between 1,200 and 2,200 parts, or often referred to as configuration items. If you think of the Cadillac or the Lincoln back then, those were the vehicles that we're talking about. But today, with the Lexus, for example, there's over 30,000 parts, configuration items that need to be managed. And it's not just about the hardware, it's about electronics, and it's the electronics that have really increased dramatically over the past 3 to 4 decades. Things were complex enough back then, but when we could satisfy a requirement simply with a mechanical mechanism. Take, for example, the door lock on a car. It used to be that little knob on the door connected to a pull lever that threw the latch. But these days, it's a combination of mechanical with electronics and software and firmware. It takes all these different disciplines to make the door lock work. You know, the button in the car doesn't throw the lever anymore. It sends a signal to a microcontroller, which interprets the signal, sends another signal to another mechanism that actually unlocks the door. And there are a series of multidisciplinary decisions which involve trade-offs in order to make that subsystem work. It could be implemented mostly in electronics with only a little bit of firmware, or alternately, it could almost be entirely software-based implementation. These aren't easy decisions, and they get a lot more complicated with large global design and engineering teams working on them in separate groups that are only focused on their own discipline and only have visibility into their own discipline's requirements. But we all know what it really starts to look like. It starts to look like more requirements, more requirements. And this is just a serious understatement because there are several thousand high-level requirements on a typical defense system, which balloons into several 100,000 detailed level requirements. If you were to make a relationship diagram of all of these requirements, it may look something like this. What this brings us to is the systems engineering V diagram, which is important to understand the development of complex systems and systems of systems. The V diagram describes how requirements flow from the product or systems concept through the different level of requirements down to detail level requirements on the left-hand side of the V into the multi-discipline implementation. And as we come back up the right side of the V through the product or system, the actual product or system that's getting built with all of these, with components, subsystems, assembly, and other components, we need to depict how traceability, verification, and validation will occur. Now in practice, most companies have had software to manage requirements. For a long time, it might be something like Doors or Slate or one of the other leading requirements management systems on the market. However, we really know what really happens. There's this sort of constellation surrounding that system where the real requirements live. You know, it's the Word documents, it's the spreadsheets, it's the slides, it's the hard copy documents that people use because they either don't have access to the requirements management system or it's too difficult to use. And those are really usually just the mechanical or hardware requirements. The software developers don't use the requirements management systems in many cases. They have their own systems called an application lifecycle management or ALM system, where the software and firmware requirements live. But then there's a constellation of documents revolving around it as to where the actual requirements live. Then you have a PLM system, which is primarily used for the mechanical information, and its own constellation of surrounding documents as well. And it's never the worlds shall meet, because not only are these systems not tied together, and the different groups don't necessarily communicate all that well either. So together, they make verification and validation difficult, if even possible, to achieve. So we all know where we're headed, to develop the systems of tomorrow with the inherent levels of complexity, which is only increasing. We've got to include more people throughout the organization and across the extended enterprise globally, and none of these systems were ever really designed to handle those scenarios or the levels of data that are commonplace, and we all expect them to continue to increase moving forward. So that's why we're bringing all of this information together. Why is bringing all this information together is imperative. In order to deliver the complex systems and products of tomorrow, requirements have to be connected directly through the actual systems design and implementation at all levels of this systems V diagram. And that's why Aras has approached and embedded multidiscipline requirements management inside the PLM system. So why requirements management embedded into PLM? So bringing it all together and having requirements management embedded in PLM, you're better able to verify that the correct system or product is being designed with the voice of your customer and your market requirements, along with the ability to keep your requirements synchronized with the overall system configuration as it goes through product changes that are inevitable in today's fast-paced world. The other important thing is to have closed-loop traceability or validation of your system, even as complexity continues to increase exponentially for years to come. But it's not just the information in Word documents, Excel spreadsheets, and presentations that need to be included. You've got to be able to include anything as a requirement. It's your Word documents, your Excel, your PowerPoint. It's PDFs, scanned documents and images, video, and increasingly videos, not just files, but also links to YouTube and other places where videos live, which means that you've got to be able to capture URL links and, of course, other items in PLM like parts, components, materials, or anything else that may be relevant to your requirement. In summary, for Aras Requirements Management and why they've embedded it right into PLM, it means that you have a highly scalable, unified data model for seamless connectivity and usability. Your people are working in a multidiscipline requirements hierarchy with the ability to securely extend access out to customers, suppliers, and outsourcing partners around the world, while you're giving users a familiar, easy-to-understand structure and document with chapters and content just like they're used to. And those requirements inherently become part of the overall configuration. They can be placed under configuration change control, so they can be identified as affected items on a change, on any proposed changes that are occurring in your system. At the end, you have everything connected better for better verification and validation with trace matrix capabilities capable of handling the most complex systems of systems, even when there's an overwhelming amount of data. With the requirements truly integrated across the lifecycle. So now we're going to step into our demo, and what we're going to have is we're going to have a quick overview of the user interface. We'll talk a little bit about the requirements management module and how it's embedded and integrated into Aras. So we've had other webinars where we've gone through basic capabilities and overviews of Aras. Just to give you a quick overview, I'm in an internet window. It's a web server, web client, the database backend with your files stored in a secure location. And I'm giving the right to log in as Innovator admin to different information in my organization or into my Aras Innovator database. I'm working on a demo database today, and it's around the MakerBot information. So I'm going to go in and I'm going to bring up a requirement document for 3D printer customer requirements. So requirements documents, if you think of them as the document, if you think of it as the Word document or Excel document, you get customer requirements. So customer A would send you some customer requirements, and they're usually indented with a 1.1 and a 1.0, 1.2. And as you navigate down that Word document, you have different requirements in that Word document that you have to deliver. The customer is going to have to sign off and validate and verify and accept as part of that customer deliverable. If I go into this requirements document, though, if you use the same paradigm as what you're getting into Word or Excel and PDF from your customer, if you think that into a requirements management document, what I have is I can break that down into individual requirements. So each line item in that requirements document is therefore its own requirement and lives on its own. So for example, this requirements document, as other objects in Aras, I also have lifecycles associated to this requirements document. So it can be released, it can be drafted, in review and released, and then it can go through change management. So other users will know when it's in change or when this requirements document has been superseded by another requirement document itself or another revision of the requirements document itself. If I look down on the bottom of the requirements, you'll notice I have individual requirements. I have information as to who they're managed by, as well that overall requirements document is managed and owned by different users. So the ability to assign individual managers and owners to individual requirements lets the electronics engineers manage their electronics requirements, The mechanical engineers manage their mechanical requirements, and your software engineers manage the lifecycle and change management of there, with somebody overall managing the entire set of requirements as indicated by the managed by and the owned by. If I go down into one of the requirements, I'm going to go down and take a look at model and material capability. Each of these requirements then has its own life cycle, then assigns its own unique owner and designated user. And those are Institute Configuration Management, CM2 identities or membership. So if I go and take a look at the life cycle of a requirement, each requirement is then subject to its own life cycle. So each requirement can then proceed in its life cycle as it needs to proceed. So requirements can be sent to in review and then they can be released. There's some business intelligence in behind this grid behind me in the requirements management where it won't let me release a higher level requirement if the child requirements haven't yet been released. So there's intuitive and business logic to make sure that your requirements are under configuration control. The requirements management UI, we've got complexity, priority, and risk. So this lets you establish some risk management analysis into your matrix, into your requirements. So a requirement may be medium in complexity, but it might have a high risk if it's not met. It might be a safety issue, a quality issue, a customer brand recognition issue. I could have files associated. I could have related parts associated. External links and outgoing links, we'll take a look at that information. And I'm just going to take a look here at where used. So we talked about requirements management being typically stored in disparate organizations or systems, and there was no integration in between your requirements management system, your software management system, your PLM system. So there was no real full traceability from the end deliverable and the sign-off that you verified that the requirement was being met back to the original requirement where it was established and set up. Embedded PLM, it allows me to, where I do a where used on this requirement, I can find out that this requirement has been associated to the MakerBot replicator, to the cover option, as well as the body. If I go into the cover body, I can then find out that that cover body was then associated with an engineering change. The body itself, I can then trace back up, basically from my requirement, all the way looking up to all the relationships and where used, and really fully understand the impact. If I was to go change this requirement now, what other things do I need to look at as the scope of that change? If I go take a look at the MakerBot replicator, I'm going to go look at this part information. So with requirements management embedded into PLM, you can link parts to requirements, one to many, and it's also in the reverse, that it's many parts can link to many requirements. So one part is, the delivery of one part is not simply met by the delivery of one requirement. This part, this cover option for the MakerBot might have several requirements that it's going to fulfill as part of your customer requirements, your market requirements, your safety requirements, software requirements. So I can take a look here at all of the different requirements that it's actually meeting, whether they're in that same unique requirements document or they're at different requirements. I can also see the state that those requirements are in. I can understand the priority and the risk and the category and the complexity of those requirements by simply looking at the part. So if you're an engineer and you need to understand what requirements were required to deliver this part, you can get to the part. And if you're the requirements management engineer or resource in your organization, you can understand the flip side as to your requirements pointing over to what parts that they're affected to or what parts they may affect. So when an engineer wants to change the part design, they can actually see what requirements may be changed. So a part that's failing, the part may need to change, which may need to change the operational requirements, which may need to change the customer requirements, which may require you to have a contract change or scope change with your customer. By having them all embedded and linked together, you can fully understand the impact of changing either a part, a requirement, or other related information. So if I go take a look at some other information in this grid, I can see that this model material capacity had a particular part associated. It's got a visual cue with this part symbol. I can also see for the requirements of the speed, for example. I can view this requirement, and I've got some links associated to this requirement. So in the slide presentation, we talked about being able to link to external links. This could be a YouTube video. This could be a specification of a industry standard that you need to meet as part of your organization. You can have outgoing links. So external links could be a URL. I actually, unfortunately, don't have one in here. Outgoing links. I have outgoing links. So this particular requirement is now linked over to the fabrication speed. So if I go take a look at the fabrication speed, so when you develop and document your requirements in your organization, when you link across the different requirements, it's basically how they come introduced into the life cycle of your organization. So your market requirements might come first, and then you might have specific customer requirements. And then as your engineers and your software engineers start working on the detailed design, you're going to get software specifications and detailed design specifications. They're going to stand up as their own requirements document, and those requirements in those detailed designs can then link back to the initial customer requirements or market requirements. So if I go take a look at this fabrication speed, that's one area. So I'm going to go take a look here at my requirements for my 3D printer. The reason I'm looking here is I believe I have an external requirement embedded in here. So this external embedded requirement can be stored in the actual text or can be stored as an external link. So this could be to a website. I can go click on this requirement so I can have users go look at the information without bringing that information into my requirement. So here's an example of an external requirement. Takes us to the Javelin web page where we can provide you with a MakerBot replicator of the demo material that was actually provided in our demo. But this URL could link to your FDA requirements, your electronic requirements, your IEEE requirements, your industry and regulatory requirements. So that URL can be tracked. So if you're referring to external sources and requirements themselves, you can point users into the right direction. So when people go to review this requirement, they can all get to the same place and there's no misinterpretation of where they need to be. So requirements management, a little bit about the user interface. If I go in and lock this item to work on it, so locking an item is typical Aras behavior. If I have the rights or the permissions to actually unlock that, or it's in a lifecycle state which will allow me to unlock it, it would allow me to go ahead and do that. If I didn't have permission, it would actually throw a message to say that you don't have permission to do this. So some of the stuff in the user interface that I can go in, I can grab a requirement, I can right mouse click, it's got context sensitive, I can insert a sub requirement. So if I wanted to insert a sub requirement, it allows me to go into the user interface. It's going to bring up the requirements window. I can go in and assign the complexity, I can assign the priority, and these blue text boxes are indicated that they are mandatory fields. I can go find a designated user. In Aras with identities, this could be a user, this could be a group, this could be a specific person. So I'm going to assign this to Aaron Lee. He's going to be the designated user. This is my new requirement. I'm just going to type some stuff in here. If I was to type better, it would be a little bit better. I could put in some descriptive text. I could copy and paste text from another Word document, have that put in. Notice I don't have a requirement number yet. Aras is just going to assign that. If I save that, it's going to be basically just the next unique number. Aras offers a different numbers of ways to numbering these, to putting prefixes in and allowing you to configure those to what your organization needs. I can go look for related parts, but when I go to actually link this to a part, I would actually go to the part and create the link from the part back to the requirement, and this is basically doing a lookup to my organization. I could go add external links. I can add an outgoing link, so I can say I need to link this to a different requirement in a different document. So I can go in, I can search for a different requirement that might be the customer requirements or the market requirements. We'll just see if we have a market for color. I'll just do a search for everything. So I can go in and say I might want to relate this requirement to my cost. Because it was related, I could link it to one or many or just one. I can go in and save and lock and close this, and now this requirement is in my requirements document. It was embedded underneath this speed. I have cost under here with my new requirement, and if I wanted to then say I wanted to promote this, I can then go in, if I have the rights and the ability again, I can go in and promote this requirement to the next lifecycle state. If that was what I needed to do as part of my organization. Moving up, moving down, the other features that it has, you can create new requirements, you can copy requirements, you can edit them, you can move them up, you can move them down, you can move them left, you can move them right. So moving it left and right, I can use these same errors, and basically it outdents and it indents it a little bit more, and so I can create my hierarchy and my tree and associate where my information is. I can take these and I can move them both over to the right, and I can indent them under the speed requirement. So it allows me to give me some structure into my requirements document, and I'm going to move this one back out just for the sake of doing that. So this particular requirement, this model durability, notice that if I say this is my requirement here, I had assigned this to Erin Lee, and I no longer have permission to do a promotion, whereas I have the promotion on this specific requirement to promote this. So I could then promote it to the next lifecycle state, and it's made sure that I have the right permission and the right group available to actually take that promotion. There's no promotions available because I still actually don't. The manager is the overseer, that's the actual user, requirements management engineer, that's allowed to promote that over. So a quick overview of the interface again. We're just going to wrap this up. The requirements document, they're related to other objects in your system. It's giving you a UI. You can batch code these requirements in. So a lot of requirements documents in our customer organization have thousands of requirements, so you can understand how complex this requirements management make grid. They're managed, they're set by identities and owners. They're managed through the life cycle of that requirements. I'm going to save, unlock, and close this. They can be linked to other business objects in your system, as well as they can go through the complete change management functions that Aras provides, as well as allowing you to configure them. So I'd like to quickly thank you for your time today. If you do have any questions, please send them along. Sarah Pugh, our marketing manager, she can answer any of your questions today, and we can get them answered. We can follow up with a link to our webinar and provide you some additional information on that Aras product and how it can help your organization manage your requirements. Thanks again, and have a great day.